On October 29, 2025, something in the solar system changed. At first, no one noticed. The sun rose as it always does, indifferent and ancient, spilling its light across the inner planets. But behind that glare, invisible to the naked eye, a traveler from another star was making history. The interstellar object known as 3I Atlas had reached Perihelion, its closest approach to the sun. And as telescopes across Earth and space turned toward that precise region, astronomers expected the familiar spectacle: a slow brightening, a long tail, a silent ballet of vapor and dust. Instead, they witnessed violence. Within hours, Atlas's luminosity didn't just climb, it erupted, doubling faster than any known cometary curve. The instrument logs filled with numbers that made no sense. "It's exploding," said Dr. Kaichang Zhang at the Lowell Observatory. His voice almost drowned by static as the readings came in. But explosions leave debris, and this one didn't. The outburst was pure light, no fragments, no plume, just a sudden radiant transformation that violated every model built to describe how frozen objects behave near a star. Something billions of years old had awakened, and no one understood why. Over the following nights, data poured in like rain. Radio telescopes captured torrents of molecular signatures streaming from the object. 5.7 times 1028 water molecules every second, 40 times the rate measured a month earlier. Imagine the energy behind that: a mountain's worth of ice turning instantly to vapor, a fountain wider than the moon, invisible except to the instruments counting its atoms. Comets do this when they near the sun, but not like this. Not this fast. The spectrographs showed spikes of C2 and NH2, carbon chains and emitting radicals that only appear when volatile ices sublimate violently. Yet the timing was wrong, and the pattern was wrong. Instead of a steady slope toward maximum activity, Atlas's brightness graph looked like a heartbeat, a flat line, then a single pulse that shot upward almost vertically. Dr. Carl Bams at the Naval Research Laboratory described it as watching a candle suddenly turn into a flare gun. The outgassing rate implied internal fractures, pressure chambers rupturing in sequence, but the geometry of the outburst made no physical sense. It was symmetrical. Natural vents burst in chaos. This one released energy as if choreographed, a pulse evenly distributed across its surface. For a moment, the idea that it was exploding gave way to something stranger. It was responding, musical note music. When the first clear images from Soho, Stairway, and GOES 19 arrived, disbelief turned to awe. Against the blinding halo of the sun, Atlas appeared not as the graceful plume of a typical comet, but as a faint, stretched ember, elongated yet tailless. The dust that should have formed a luminous trail millions of kilometers long simply wasn't there. It was as though radiation pressure, the very force that sculpts every cometary tail, had been switched off. The comparison with Comet Lemon, photographed under identical conditions 2 days earlier, was almost cruel. Lemon displayed the archetypal curve of gas and dust arcing away from the sun, while Atlas remained a single wound of light, self-contained, unmoved by solar wind. The coronagraph images looked wrong to every trained eye. Some proposed that the outburst had vaporized only gases, leaving no dust to scatter sunlight. Others suggested that CO2 escaping months earlier had cooled the nucleus so efficiently that, when that reservoir emptied, the newly exposed ice detonated in one synchronized flash. But deep down, researchers felt the unease that no theory erased. The outburst was too exact, its geometry too controlled, as if some invisible hand had timed the event to perfection. Then the James Webb Space Telescope stepped in. Using its near-infrared spectrograph, Webb peered through the coma and saw what no ground instrument could: a surface utterly transformed by the violence of interstellar space. For billions of years, galactic cosmic rays, high-energy particles from supernovae and black hole jets, had bombarded Atlas, each collision rearranging atoms, splitting molecules, forging new compounds. Simulations by Dr. Roma Mazzio at the Royal Belgian Institute for Space Astronomy showed that radiation had penetrated 50 to 65 feet into the nucleus, creating a deep irradiated crust where ice had fused with carbon to form complex polymers. The result was a shell harder than granite and chemically alien, a crust that absorbed sunlight instead of reflecting it, storing energy until something finally cracked it open. The explosion at Perihelion might have been that moment, the instant the armor failed. But Mazzio warned that calling it failure might be wrong. The crust could have functioned like insulation, controlling heat flow until a threshold temperature triggered release. It's possible, she said, that Atlas didn't erupt spontaneously, it activated. The word hung in the air like static. If the outer shell is radiation's masterpiece, what hides below it could be a time capsule from another star. The question obsesses astronomers. Is there pristine material sealed under those 60 feet of altered matter, untouched since its birth billions of years ago? If so, the explosion might have exposed that ancient core, matter older than the sun, formed under conditions humanity has never observed. But there's a darker possibility. If the bombardment lasted long enough, the transformation may go deeper, turning the entire body into a single composite unlike any natural rock or ice known. Webb's data can't yet tell how far the alteration goes. It only reveals that the surface no longer behaves like frozen water. It behaves like something engineered by radiation itself, self-reinforcing, self-protecting. And that brings us back to Professor Avi Loeb, who publicly urged NASA to release every dataset, every raw frame, every spectral line collected on 3I Atlas. He framed it as scientific transparency, but his wording betrayed urgency. If this object has secrets beneath that crust, humanity deserves to know them. His request wasn't conspiracy. It was recognition that we might never see another visitor like this in our lifetimes. In Germany, Dr. Susan Fallner proposed a hypothesis that reframed the entire story. What if interstellar objects such as 3I Atlas aren't leftovers, they're planetary seeds, the unfulfilled beginnings of worlds? Her simulations of star-forming regions show that millions of such bodies drift through young stellar nurseries, and that massive stars can capture them temporarily, letting them act as nuclei around which planets coalesce. It saw things our species can't imagine. It survived epochs that erased entire civilizations, if any existed. And then, against all odds, it arrived here on a path so precise that it brushed past our planets and ignited beside our sun, just as our species had built the instruments capable of seeing it. That timing alone should make you shiver, because maybe it's not a coincidence. Maybe the universe doesn't deal in accidents. Maybe it deals in moments. Right now, as 3I Atlas drifts back into the abyss, fading beyond Jupiter's orbit, all that remains of its visit is data, columns of numbers, graphs, and spectra that scientists will argue over for decades. But behind those data points lies a deeper truth. Something ancient reached across time and space to remind us that we are not done learning, that the universe still hides miracles in plain sight, and that we have barely begun to understand what's out there. Whether 3I Atlas was a natural relic, a fragment of a shattered world, or a probe from someone else's imagination, it did what all great mysteries do. It made us look up, question everything, and realize how fragile our understanding really is. Maybe billions of years from now, long after humanity is gone, 3I Atlas will pass by another star, and another civilization will notice it. And they, too, will ask the same question we asked. What was that? Maybe that's how the universe communicates, not with words or signals, but with visitors like this, drifting between suns, carrying questions instead of answers. So when you think of this story, don't think of it as a comet that exploded. Think of it as a conversation between us and the cosmos, between the known and the unknown, between curiosity and eternity. Because every once in a while, the universe doesn't whisper, it roars. And if you're lucky enough to be alive when it does, you have a responsibility to listen. If this story made you question what's possible, don't let it fade like the light of Three-Eye Atlas. Subscribe to this channel because we're not done following what happens beyond the stars. Turn on notifications. The next discovery might already be on its way and you won't want to miss it. And tell us in the comments, do you think Three-Eye Atlas is natural or something built?